Coulomb's law. This is today's topic. Coulomb's law, this is used for the calculation of force between two point charge masses. Yes, they should be point like substances or masses. And between these 2 point charges, the force of attraction or for the force of repulsion, these can be calculated using Coulomb's law. When force of attraction is there, when there are like charges, say both the charges are positive or both the charges are negative, so these are called like charges. So in this case, force of repulsion will be acting in between them. And for unlike charges, okay, in that case, force of attraction will be acting in between them. Say one particle is positive and one particle is negative charged. Positively charged particle and negatively charged particle. If the particles are not charged, if the objects, means charged objects, are not particle likes, then in that case calculation will be somewhat different. But in case of spherical charged masses, okay, whenever I am talking about masses, I am using the word masses, that means it is not point-like. It is more than a point. Means it is a three-dimensional object. So if the charged objects are spherical and if the size of the objects, means those charged, those spherical masses, if the size are small as compared to the distance of separation between them, and distance is measured from center to center of one sphere up to the center of other sphere. This way, distance, straight line distance along a straight line is measured. Okay, so what is the law? Law is, there is a similarity between Newton's law of gravitation and this law, that is Coulomb's law. Here, force of attraction or repulsion is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Once again, I want to mention the same thing, that distance between them means it is distance from center to center, or for point charges from one point to another along a straight line joining the 2 points. Straight line joining the 2 points. Along that line, force of attraction or repulsion will act. So here also, there will be one constant of proportionality, and which is denoted by K, capital K. I have written here, capital K, this K. The formula can be written, Coulomb's law can be written this way: F is equal to K mod of Q1 into mod of Q2 by R square. This is R square, okay. R is the distance between the point charges. Q1 and Q2 are the charges, and mod sign has been used to take positive. Okay, to make the positive, because one charge may be positive, another charge may be negative, both the charges may be negative. Okay. Here, this way if you calculate, force will be always positive. And depending upon whether they are like charges or unlike charges, it will be either attraction or repulsion. If like charges are there, then repulsion will be there, and for unlike charges, attraction will be there. That is known to you. Okay, that sign you have to decide logically. So this K is constant of proportionality, but this K is written as 1 by 4 pi epsilon 0. Why this is made so complex? K is constant of proportionality, and experimental value of this is equal to this one, 8.8541878172 into 10 to the power minus 12 Coulomb square per Newton meter square. That is the experimental value of K. And this law is also experimental, Coulomb's law. This law was found experimentally by whom? By Charles Augustin de Coulomb. full name of Coulomb is Charles Augustin de Coulomb. Okay, so he found experimentally this law, and when K is written as 1 by 4 pi epsilon 0, then in that case this is not the value of K, this is the value of epsilon 0. Okay, if value of epsilon 0 is equal to 8.99 into 10 to the power 9, there is a mistake. This should not be written here, this is actually only epsilon 0. Okay, this is the value of epsilon 0. So, if you write this way, K is equal to 1 by 4 pi epsilon 0, you will get advantage while dealing with electromagnetism. Because in most of the works related to this, force of attraction or repulsion, or for electrostatics or current electricity, in most of the cases, instead of using Coulomb's law, what we need is law of electromagnetism. And while using those things, if you write K is equal to 1 by 4 pi epsilon 0, then that will be advantageous to deal with. That's why this is written this way. But whenever you are studying Coulomb's law only, and in that case if you write K is equal to 1 by 4 pi epsilon 0, you may think that why this is written so complex way. Okay, so reason is this, that this law is of rare use. Okay, in most of the cases law of electromagnetism is used, and in that case if you use instead of K 1 by 4 pi epsilon 0, if you use, then you will get advantage. Advantage means what? Advantage of simplicity. You will get simplified forms of the equations. Okay, so this is all about Coulomb's law, and this law is also applicable in case of quantum mechanics. You know, electrons rotate around the nucleus, so the force of attraction between the nucleus and the electrons can be calculated using this law, Coulomb's law. Again, you know that atoms combine together to make molecules, so force of attraction between the atoms can be calculated using this law. Again, for any liquid or solid, the force between any two molecules or between one molecule and another atom can be calculated using the same law, that is Coulomb's law. So you will find application of Coulomb's law in case of quantum mechanics also. Okay, and there is a similarity between this Coulomb's law and Newton's law of gravitation. But the difference is that in Newton's law of gravitation, all the masses attract each other. There is no repulsive force. Gravitational force is always attractive in nature. Okay, but in case of charged particles, there may be attractive force, or again there may be repulsive force. It depends upon their signs. Okay. And in most of the cases, in our daily life experience, if the force is not gravitational, then in most of the cases you will find the force to be this force, electrostatic force. This force is also called electrostatic force. Okay. This law is known as Coulomb's law. Again, this is also known as Coulomb's inverse square law. Okay. So this was all about Coulomb's law. Thank you. Thank you for watching this video.